3D radars of the Joint Surveillance System. As previously mentioned, the JSS consists of over 100 long-range radars shared by the FAA and the U.S. Air Force. A number of these radars, mainly located around the perimeter of the U.S., are 3D primary radars. This means they are capable of estimating the altitude of primary returns. Remember that a primary return is the echo of a radio pulse. A secondary return is an automatic message transmitted by an aircraft's transponder in response to a signal from a secondary radar. Older technology radars are sometimes referred to as 2D because they cannot estimate altitude. This is due to the shape of the radar beam. The groundbreaking SAGE system combined range height finding radars with 2D radars. SAGE stands for Semi-Automatic Ground Environment. The system was only semi-automatic because the range height radars had to be manually directed to point in a chosen direction before they began their vertical scanning. SAGE was replaced by the JSS. For a list of Joint Surveillance System radars, refer to Wikipedia. Look for ARSR-4, which are the 3D radars. We are now aware that both the FAA and the USAF will supply recorded radar data in response to Freedom of Information requests. However, only the Air Force will supply 3D data. As an experiment, I requested 4 hours of data, on a randomly chosen date, covering most of Florida. This was because Florida has 6 3D radars. In response, the 84th RADES provided data from 22 radars. The following animation shows data from only 4. You should be able to see a crude outline of the Florida coastline, as well as a brown line indicating the path of a selected target. When I requested the data, it was with the hope that I could find an example of multiple radars detecting an object that didn't have a transponder. This would allow me to compare the altitude estimates of each radar. From experience, I knew the probability was high. The brown line indicates the path of an assumed aircraft. It flew from the west coast of Florida to the east coast, continuing over the Atlantic, where it disappears out of range, probably traveling to Bermuda. Its average speed was approximately 200 miles per hour. All 4 radars detected elements of its journey. Using these data, I was able to create the following graph of estimated altitude against time for each radar. We would expect to see smooth, close, parallel lines. This is not the case in this instance. From this initial data, it would appear that only one radar seems to be returning consistent estimates. There may be a number of reasons for the variances, but these initial findings are a little disappointing. A few questions come to mind. Is the JSS being adequately maintained? Will current radars be upgraded with more modern technology? There are certainly other countries with newer 3D radars. Perhaps, in the future, it will be possible to analyze sampled data from these installations as well. By researching today, we are, at least, preparing the way for tomorrow's investigators. Thank you for listening.